Hi, my students. Today we're going to talk about another type of factoring technique, which is called general factoring. So this is the type of factoring that you're going to use most often. Okay, and we use general factoring with a quadratic, which if you remember, what is the highest exponent in your polynomial if you have a quadratic? That is when your highest exponent is a 2. Okay, so when your highest exponent is a 2, this is when you can use general factoring. And typically when we use general factoring, you must have 3 terms. Okay, so a difference of squares you use when you have 2 terms and you're subtracting. And don't forget they also have to be perfect squares. Okay, so if you have 3 terms in a quadratic, that's when you're going to be using general factoring. Okay, which most of the time general factoring will work to factor your polynomial. Sometimes it won't work, but talk about what happens later on when you can't use general factoring. That will be for another day though. Okay, so before we get started, we're going to talk about general factoring when a equals 1, which a is going to be your leading coefficient. Now, when we have a quadratic, your standard form is going to be written just like this. So standard form is going to be ax squared plus bx plus c. Okay, so a is always going to be the number that is in front of the x squared. B is going to be the number that is in front of the x to the sneaky first power. And C is going to be the term that does not contain an x, which is called your constant term. So this is called your quadratic term, your linear term, because it's to the first power. And this one is called your constant term because, don't forget, if you don't have an x, secretly, it's x to the 0 power, which is a constant degree. So constant degree, linear degree, quadratic degree. Okay, so let's get going on example 14. Sorry, guys, I was trying to zoom in and it wasn't zooming in. Sorry, it was a little awkward for a little bit. But anyways, let's keep going. So, I have 3 terms, and my highest exponent is a 2, which means I have a quadratic. So this is giving me a hint to try to use general factoring. Now, you have probably learned about general factoring before. Probably in a previous math class. Okay, I'm going to teach you how to factor using a technique called slide and divide. There are lots of ways to factor using general factoring. So if your previous math teacher taught you how to factor this in a different way and you prefer that, you can use that technique. But I'm going to show you slide and divide. So just give slide and divide a chance. If you hate it and you like the way that your last teacher taught you how to use general factoring, you can do it that way. It will not hurt my feelings, I promise. Okay, well, let's get started. So before we start sliding and dividing, I like to identify the A, B, and C in my quadratic first. Okay, so the A is the number that is in front of the x squared. So the number that is in front of the x squared, I don't see a number. Which, don't forget, if you ever don't see a number, there's secretly a 1 in the front. There's a sneaky little ninja that's in the front. It's there, but you can't see it. Okay, so my A value is the 1. It's the number in front of the x squared. The B is the number that is in front of the x to the first power, or just in front of the plain old x. Okay, so the number that is in front of the plain old x is this -6. That negative sign is attached to the 6. So -6. And the C value is the number on the end that does not have an x, so the constant term. So in this case, it would be a 5. Okay, so now that we have identified the A, B, and C, now we can start sliding and dividing. Get excited. Okay, so what I'm going to do first, I'm going to call it slide. Okay, I'm going to slide the A value to the C value. Now, when I say slide, what that means is I'm going to be multiplying. So, slide is a code name for multiplying in this case. So, I'm going to slide my A to my C term. So, slide A to C. All that means is I'm going to multiply A to C. So, my A times C, 1 times 5 is 5. So, first, you slide A to C. So, slide. The A times the C is technically the slide in the slide and divide. Okay? Now, before I keep going with this process, this technique is called slide and divide. Okay, a lot of my students, they are great at doing the sliding part. They can slide all day long, but then they forget to divide. So the divide actually doesn't come into play until the very end of the problem. I'm going to go ahead and divide though, because this is the part that a lot of my students let the demon cats get them and they forget to divide at the very end. Okay, so we slide by A, we slide A to C, and then we're going to divide by A. So A is going to slide and it's going to divide. So at the very end, you're going to divide your answers by the A value, which in this case, my A value is a 1. So at the very end, which this is not going to make very much sense until the very end. Okay, so just bear with me. But at the very end, we're going to divide by A, which in this case is a 1. Okay, so we slide A to C. We also need to identify the B, which the B is the number in front of the X, which is -6. Okay, after we slide A to C and identify the B, what we need to come up with are two numbers that will not only multiply to be a 5, but will also add to be a -6. Okay, so these two numbers have to be the same numbers as these two numbers. These two, the ones that you use when you multiply, don't have to be the same, but whatever you use to multiply, you got to use to add. Okay, now something else to keep in mind, you guys. Whenever you are multiplying to equal a positive number, don't forget two positives multiply to be a positive. Positive times positive is a positive. Do you guys know anything else that will multiply to be a positive? Holy hot dog, you guys always know the right answer. Also, a negative times a negative equals a positive. Guys, so these two numbers might both be positive or they could both be negative. It really depends on what you're going to add to equal, which if you guys see here, we're going to add to equal a negative. So it's really hard to add two positive numbers to get them negative. Okay, so this is kind of giving me the hint that I'm going to end up with two negative numbers. So I'm going to prepare myself for the negatives that are going to be coming. Okay, so I know I need two negative numbers that will multiply to be a +5 and will add to be a -6. Well, the only thing that multiplies to be 5 is 1 and 5. So let's see here. Does -1 times -5 equal 5? Yes, it sure does. And does -1 times plus -5 add to be -6? It does. Okay, so if you see here, these two numbers have to be the same numbers you use on this line. Okay, and they have to work in both cases. So -1 times -5 does equal +5, and -1 minus 5 more gives me a -6. Okay, so after you determine the two numbers that will multiply to be A times C, which is your slide, and add to be B, I'm going to move these numbers into here. So I'm going to slide my -1 down here. So I'm going to write -1. And I'm going to slide my -5 down here. So I'm going to write -5. Okay, so these numbers, which are the same in both lines, we're going to put into a parentheses with an X. So we're going to have X minus the first number, which is -1, and X plus or minus the second number, which is a -5, so -5. Okay, and then we divide by A, which happens to be a 1. Okay, for my final answer, I'm just going to simplify whatever I get. So for my final answer, I'm going to simplify my fractions. So a -1 divided by 1 is a -1, so -1. And a -5 divided by +1 is a -5. So guess what, you guys? We have just Sorry, got a little too excited. We just factored using slide and divide. And don't forget, you guys, if you ever redistribute out your factored form, you should end up with your original answer. So if I do like X times X, that gives me X squared. X times -5 is -5X. -1 times X is -1X, which we know -1X minus 5X gives us -6X. And -1 times -5 is +5. So if you see here, we end up with what we started with. Okay, so if that process didn't really make sense to you, don't you worry. It will make more sense after we do example 15 and 16. I pinky promise. If not, you better be raising your hand so I can help you. All right, well, let's get going on example 15.